when we're dealing with quadratics, a common application style problem is to say we have an equation, and this equation tells us the profit as a function of the number of salespeople. Or it could really be anything, but you're going to have an equation, and you need to find the maximum of this equation, or the minimum. The idea, though, if you step back a little bit from the nitty-gritty algebra of how we do this, and just look at the big picture, what have we got? That's a parabola. Okay, so we've got some kind of parabola like this. It's not a great drawing, but just bear with me. And we want to find the peak, the maximum. Well, if you remember, we have recently talked about this thing called vertex form. And vertex form is very, very useful for finding the maximum of a parabola. Here's vertex form. And h and k are simply the x and y coordinates of that vertex right there. So if you can find h and k, you're done. The whole problem's done. And we don't need to do the whole completing the square hokey pokey thing. We can just drive at this much quicker. If you remember one special formula, h equals negative b over 2a. Okay? Now, you can see where a is. I already wrote that right here. That's a. But what about this b part? Well, remember what standard form is. Standard form is the following. A x squared plus b x plus c. Okay? So if I just plug in b and a from the equation I'm given, I should be able to find h, which is the x coordinate of the vertex, which in this problem is the number of salespeople I have right here. Okay? So let's give that a try. I'm going to say h equals negative b. Well, b is 84. So negative 84 times 2 times, or divided by 2 times negative 2 in this case, because a is negative 2. Okay, so what do we get? Looks like 84 divided by 4, and that is 21. So maximum profit occurs when I have 21 salespeople. Fewer than 21 salespeople, and there's not enough guys to cover the whole block. More than 21 salespeople, and they're just standing around talking to each other because they're bored. So this is the optimal number. Now, how about the y value of that vertex? Well, you might think you have to go into completing the square here, but I'm going to just point out something very convenient about the way functions work. P of x is this curvy thing. Now, what's the point of a function? The whole job of a function is you plug in x, and the function tells you what y is. So if I plug in h, the function tells me k. It has to. That's what it does. So we're going to say k equals p of, and I'm going to plug in h right here instead of x. Well, let's see what that does. Negative 2 times 21 workers squared plus 84 times 21 workers minus 722. So some of the numbers here are a little big. 21 squared. I don't know if I want to do that in my head. 441? Maybe. 84 times 21, I do not know. So let's pull out the calculator here. 84 times 21. Okay, that's a big one. 1764, and then minus 722. So you see, at this point, all we have is some number crunching. And everyone knows how to use their calculator for this sort of stuff. This is what they were made for. So blah, blah, blah. 722. Okay, here's what I got at the end. 160. K equals 160. That means that is the maximum profit. That's the height of this vertex. So $160,000 is the most I can squeeze out of this company.